Hey everyone, welcome back to a new video. In this video, we'll talk about MVI architecture for Android. So we'll talk about the components of that architecture, then I will show you how to implement this architecture for Android. And now let me actually show you the application that we will be building in this app. However, this application is very simple, but the focus here is on the MVI architecture, not on the app itself. So let me show you the app now. And now the app is starting. As you can see, we showed a progress bar, and then we fetched some data from the internet using Ktor. So we'll be using Ktor for HTTP connections. And if you don't know Ktor, this is actually okay. And Ktor is just a library like Retrofit to just make HTTP connections and get data from an API or so. As you can see, these are a list of posts from a fake API that we load in, and we just use MVI architecture to get this list of posts. Okay, so as you could see, this is the global MVI architecture. However, MVI is not only used for Android, so it's used in web, used in Flutter, in React Native, so pretty much in all platforms. So this is MVI architecture. And before I explain the architecture components, if you don't actually understand things in this video, it's totally okay. So what I recommend you to do is to watch the theoretical part. So when I explain these components, watch this part, then move to the practical part where we actually build the application. After that, get back and watch the theoretical part again, and I promise that it's gonna make much more sense to you. This is how I personally studied MVI. So without more talking, let's actually explain these components. Basically, we have two colors in this architecture. We have blue, we have red. Now let's take the blue section here, the blue components of this architecture, and you probably know what this is. We have view, the view sends an event to the view model, the view model returns a state. So this is MVVM. I think most of you know this architecture because it's the most common one in Android. If you don't know that, it's very simple. So we have here a view, the view sends an event to the view model then decides what to do and send back the state to the view so the view can render the state. Now one thing is missed in this architecture is the model. So in MVVM we also have the model, which is typically could be a repository or maybe use cases. So here we would have model. And now so far we have MVVM architecture, like nothing new. Now MVI actually is built on top of MVVM. So as you can see, by adding these two components, the red components, we get MVI. And now let's actually take a look at these red two components. So here we have the container, which is the store. So the container here actually has the state of your screen, for example. So the container is just a state. Then we have the reducer. The reducer here will determine what to do with that state, depending on the intent that we pass in here. Now let's go back from the beginning and just go with the flow. Okay, so we have the view component here. The view component sends an event to the view model. An event could be a button click, for example. Then the view model will translate that event into an intent. And here the intent and the event could actually be the same. So for example, when the user clicks on the login button, the view model gets that, then the view model will translate that event into an intent, which will also be a click, like a login click. Then the view model sends that intent to the container, and the container here, as we said, has the state of the screen. Then that container will sense the current state. So because the container has a state, so it will send the current state, and will send the intent that got from the view model to the reducer. Now the reducer will determine what should do with the current state depending on the intent. So for example, in the app that we will be building in this video, the intent would be GetPost intent. Then the container or the store would be all the states that we have in that specific screen. So we have progress bar, we have list of posts. So yeah, we maybe also have an error. So these are the states and those are inside the container. Then the reducer will get those states, will get the intent, which is GetPost, and modify on that state, then return it back into the container. Now the container again will return that state into the view model. The view model will send that state to the view, which will render it and show the new results. Now this might be very confusing for you. It's actually okay. By implementing this architecture, you will understand it much and much more. Now, if we actually take the V from here, and if we take M from the model, and if we also take I from intent, we will get VMI, and if we reorder this, we will get MVI. So that's how we got MVI name. We take V from view, I from intent, or M from model, then I from intent, and we get MVI. Okay, now enough talking, let's implement this app using MVI architecture. And before anything, make sure to download the initial project from the repository link on my GitHub. I will leave the link in the description because we have a bunch of dependencies in here. Because actually, if you take a look at the architecture, you can see we have many components in here. We have container, we have reducer, and we don't want to implement those on our own. There's a library called Orbit MVI which will actually implement those components, and we're just gonna reuse them. So we have ViewModel dependency, we have compose one because we're going to use compose in this project. Then we have Ktor here. As I told you, we're using Ktor instead of retrofit because all of my videos are using retrofit, so I would like to change. And as I said, it's totally okay if you don't know Ktor, and I actually enjoy this one more than retrofit. So it's actually gonna be a good point if you don't know Ktor because you're gonna understand it as well in this video. Then we have this serialization library. This actually used to change the format of JSON file into a Kotlin object. And for the REST API that we will connect to and get the posts from this one, as you could see, has like 100 posts, I think. Yeah, so 100 posts. And I will leave the link of this API in the description. So these are fake data, of course, and we're gonna use them in our app. Okay, so now let's start by building the post model or the post data class. So inside the root package here, create a new package, and the data here is from the network. So I will call this network. Then I will call this model, and you might feel confused about the model here and the model in the architecture. This is actually the same, but sometimes we represent this model by a repository or a use case, because a repository at the end returns data class like a post, and same thing for the use case. So a model here that we're gonna create now is the same one that in the architecture, which is the post model. So now let's create that and let's call this post. This will be a data class, and now let's see what the post has. So it has user ID, title, and body. So let's create those. So we can say val post ID integer. We have ID integer. We have title string, and we have body, which is also a string. Can delete these curly brackets, and now we want to annotate this with serializable because, as I told you, we want to convert the JSON format into a Kotlin object, and the Kotlin X serialization library will help us to do that. So we can now delete that and import it in here. And that's it for this model. Now we can close this, and now let's actually create a helper class that's gonna tell us the state of the data. So I will call this data state, and other people call this resource. I used to call it resource, but I think data state this name makes more sense. So I'm gonna call it like this, and this will be a sealed class. So let's call this sealed class, and here we actually define the states of the data that we get in from the API. So on the one hand, the data here could be in the loading state, so we can say data class loading, and in here we want to pass boolean. So val is loading, which is boolean, and we extend it from data state. The second state here is success. So if we got the data without any issue, that would be success. And here we want to pass the data. And for that, we want to make this generic because we don't know the type of data that we are passing. And we want to add the generic in here. And we want to also make this generic. Then this one also T. And here we can say val data, which is T. And we extend from data state like that. Then we have the error case. So we can say data class error, and here we pass the type of error. So I would like to create another cd class to determine what do we want to do in case we got an error or the type of errors that we have. And we'll call this UI component. So this will determine what kind of UI component to show when we have an error. In here we'll call this UI component. And let's see, actually we can have many components in here. So in our app, we're only gonna show a toast when we get an error. So I would like to create that class in here called toast. And for that toast, we want the text, which is a string, val text, string, and then extended from UI component. If you want to add more things like, let's say, maybe snack bar, so we can duplicate this, call this snack bar. You could also create dialog, for example, dialog, and for the dialog you would pass the title and the text or the message. And yeah, so make sure to add all the UI components in here, but as I said, in our example we only need toast. Now I'm gonna comment this, and in here we're gonna add UI component in the constructor, so we can say UI component, which is a UI component. Let's also make this val and add the generic in here. Then we extend it from data state and we add the generic. Okay, so that's it for the data state class. As I said, this one is going to help us to determine the state of the data, and this is very useful, especially when we use flows. You will see that in this video. I use a very good approach and I'm pretty sure that you're gonna like that. Anyways, now let's actually create the API to get the post, and now I'll create it inside the network package. And let's call this post API. Now for this API, what we want to do is to get a list of posts. So let's create a suspend function, get posts. And this function, as it says, will return list of posts, like that. Now we want to implement this function on our own. If you actually use retrofit, you used to just annotate this with get, and you just pass the extension of the URL in here. But in Ktor, this is not the case. We need to implement this API on our own. So let's create a class and call this post API implementation. In here, we're going to implement post API, and we're going to implement GetPost function. Okay, so now how to get data using Ktor from an API? Well, we first need HTTP client instance from Ktor. We can pass that into the constructor. We can say private val HTTP client. As you can see, it's from Ktor client. Then we can use that instance to create a GET request. Inside the GET request builder, we here can specify the URL, and we're gonna pass the URL. I will leave that in the description. Pass it as a string. Then we call body on that. And here we specify the data that Ktor will find in this, and it's a list of posts. Let me delete this S, and now we want to return this. Now Kotlin is smart enough, so it actually recognized what is the type of this body, so we can delete this generic from here like that, and we're good to go. That's it for our service, for our post API. Now we can actually create a use case to use this function and retrieve list of posts. So let's create that use case into the root package. In here we can create a use case and call this GetPost. And in here we want the post API. You can say private val post API, which is a post API. And in here we're going to have a function execute to execute that use case. And this function now will return flow of data state of list of post. We can open curly brackets, so this might seem confusing. So we're returning flow. That flow has data state, and the type of that data state is list of posts. You're gonna see the use of this soon. Anyways, in here we are returning flow builder, and now we finally use the post API. But before that, let's actually wrap everything with a try and catch block, because we are dealing with networking and we just catch an exception that might happen. Let me remove this, and in the catch block we can actually print to the stack trace, and then we can actually emit data state dot error, and inside here we pass UI component. As I said, I'm only gonna show a toast. Then we actually pass the message, and if this null, we just pass unknown error. Now in the try block we can say val post equals to post API dot get posts. Then we can emit that list of posts. So we can say emit data state dot success, and we can send the post. But one thing is missed is the loading state, so we can emit that in here. We can say data state dot loading, and we can pass through. And finally, when everything is done, so here we can add finally block. This finally block will be executed either after the try or the catch block. So in here we can actually copy this one and make the loading false. Now let me get back to the architecture and show you what we have done so far. So far we only created the model and we set up the API that we're gonna connect to. Now we're gonna create the view model. So let's go and create that. Inside the root package, let's actually create post view model. And we just gonna extend it from view model. And in here, we actually want to get the use case. So we can say get post equals to get post. And in here, we wanna create the post API. Now the post API here, which is the post API implementation, requires an HTTP client. For that, I would like to create it inside here. So I would like to say companion object, and in here we can say val HTTP client. And to create that client using Ktor, we have something called HTTP client. This is a class. In here you specify the engine, and there are different types of engines. In our case, Android, because this could be also used in a multi-platform. And in here, the device is just Android. That's what we are basically passing in here. And inside here, we can install some features. So as you can see, we have the access to the install function. And what we want to install in here is the serialization library from Kotlin X. Because we want to tell Ktor, hey, look, we have the serialization library that is gonna take the JSON format into a Kotlin object. So this is called content negotiation. So use this, open curly brackets, and inside here you actually tell the type of the file that you get from the API. So in our case, JSON. There's also XML, but I have not added the dependency for that. So let's actually type JSON in here. And inside here we have, you can actually pass a JSON builder. And the JSON builder gives you more accessibility to some fields, like ignore unknown keys, set that to true. This means that if there are unknown keys that got from the API or maybe that included in the post class, simply ignore them. So let me go to the post model here, and let's say we add some unknown key here like val unknown. This is string. Now this one is not included in our API, and by including this property here, we basically tell JSON that if you find something unknown, just ignore it. And now let's actually delete that because we don't need that. And now we can create function. We can call this provide post API. This will return a post API. And we can make this equal to post API implementation. And we simply pass the HTTP client. I'm not gonna use any dependency injection libraries here, so that's why I created this function. I also created this one in here. If you had a dependency injection library like health, for example, you would put these inside a module and just to provide that inside that module. But as I said, we don't have dependency injection in this project, so I will just keep everything simple and I will just provide them inside this companion object. Now we can get back to the view model and we simply can say post API dot provide post API, and now we have our use case. Now let's actually go back to the architecture. Now we are in the view model, we are here, and now let's actually go on to create the view state, the state of the app. In here we can create a new class, and I'm gonna call this post state. This would be a data class. So in here we just define the states that we have on the screen. We have the progress bar state. This is just a boolean and we can make this false initially. We have the post, list of posts. And we can also make this empty list. We also have error, so if we have an error, and we can make this initially null. Then we can get back to the view model. And now how do we create a state? Well, for that, using the Orbit MVI library, we need to extend it from container host. Inside here you need to pass the state. So post state, and the side effects. Here the side effects are just like the UI component class that we've defined. So UI component, and here as you could see they are required us to override this container which has the state. So now we can delete this get and we can just make this equal, and we can say container, and now we define the initial state. So in our case post state. Now back to our architecture, we created the state and we created the container, and now we want to work with the intent and with the reducer. So let's actually do that. In here we want to have a function called GetPost, and let's close that. Now in the GetPost function we want to have an intent. So inside this intent we define what we want to do for this function, and by the way this is a suspend block, so you can call suspend functions inside here. And in here we want to just execute the use case, so we can say val posts equals to get posts dot execute. Now in here we will get a flow of data state that has list of posts. In here we can actually just collect that flow and say posts on each, and we can launch that inside the ViewModel scope. Can say ViewModel scope, and this is actually equivalent to launching a ViewModel scope and collect the data state in here, collect. But I would like just to do it in the other way, like this. And inside here we can actually have when to check for data state. In here we get the data state, and we can check for that when that data state is data state loading. In here we want to change the state, but before that let's get back to the architecture. Now by looking at this architecture, the reducer here is the one that's responsible to change on the state. So in here to change the state we need to use the reduce block in here, and now we can change the state. And to access the state we can actually say state.copy, and we have an access to this state because we are implementing container host here. And now to change the state we just use state.copy, and we just need to change the perks bar state into data state.isLoading. Okay, now for the other state, for the success state, in here we can say reduce, and we want to change the list of posts, so posts, and we can say data state.data. Now is data state.error, and inside here we need actually to have another when, because the error could have a UI component. So we can say when data state UI component, and here we check for the UI component. If it's UI component dot toast, which is the only one that we have, in here we can also reduce the state. We can say state.copy, and we just change the error here, data state.UI component.text. Or what I recommend you to do actually in here is not changing the state. So let's actually go to the state, and let's actually, not here, actually the state, the post state, this one, and let's actually delete the error here. Let's go back to the view model and let's delete this state. What you can do actually, and what you can do here is to post a side effect. As we said, a side effect is just a UI component, and we can say UI component, and that UI component is a toast, and here we say, or we just pass the data state UI component.text, so the text of that error. And yeah, you can actually use the way or the method that you like. Now going back to the architecture, now we are done with the view model, we are done with the container, we are done with the reducer. Finally, we're ready to work on the view component. Let's go to the main activity, and let's remove these default things we have in here, and here as well. And now let's get an instance to the view model. So we can say val view model by view models, and we want to get the get post or post view model. Inside here, to get the state, we simply can say val state by view model dot collect as state. And here I think we need to import that, and we have this extension function because we are extending from, or we are implementing this interface. So we have the access for collect state for the view model, which is, I think, is creative. Now inside here, we want to create a lazy column. So we can say lazy column, and we can add a modifier to take the maximum size. Then we can add vertical arrangement to add some spacing between the items. Space by, we can add 5 dB. Then we can say items, and in here we pass state.post, and we need to import that. So I would just click Alt and Enter, and in here we're just gonna have a column with 2 texts, one for the title of that post and one for the body. So in here we can get the post in here actually, and we can say post dot title. The style is, can add style to that, material theme dot typography dot h6, and we just wanna change the font size and make this 18 SP. Now I'm just gonna copy this, paste it for the body, and we can make this body one. We can change the size to 10. Now we also want to show the progress bar. We can do that here. We can say if state.progress bar, then we want to show that progress bar. We show that into a box. Fill max size, we want to put that in the middle. So content alignment, we make the center. Then we just show circular progress indicator. And one thing is missed is the side effects, like the toast. So we want to collect that in here. We can say ViewModel.collect side effects. In here we can delete this, open curly brackets, and we can check for our side effect, which is UI component. So we can say, let's actually rename this UI component. Oops, so like this. We can check for that. And if that's a toast, we can actually show a toast here, and we need the context, so I'd like to get it in here, which is local context.current, and inside here we can say current, or inside here we can pass the context, and we can pass the message, so UI component.text. And that's actually everything. So we're done with all of these components, and we created each one of them. Now one thing is to add the internet permission and run the app and test everything. Okay, just one thing here, the compose compiler. I think I've not updated the version of that, so we just need to make this 142 sync now. Let's run the app again, and nothing is showing. The reason is because we have not called this function from the view model. So I'd like to say GetPost, and now we can actually get the post. And oh, okay, as you can see, at least we got an error. It's okay, we got an error, we fixed that now. But as you can see, we actually showed the side effect. And if you return the device now, we won't, oh, that's actually big. So if we return the device now, we have not got that side effect again. This is very, very cool with this library. I actually like it. Now let's actually try to fix the error that we got probably from Ktor. Let's take a look at and as you can see, field post ID. I think we have missed naming here. Okay, so this is user ID. We can go to the post model and fix that. We can say, oops, not here, user ID. Now launch the app again, and we would see the posts normally. And yeah, that's actually very good. We got the posts and everything works with MVI architecture. Okay guys, so this is the end of the video. This might be a long video, but I think I explained everything you want to know about MVI. And if you want me to create a just bigger project on the MVI architecture, make sure to comment down below in this video. And thank you so much for watching. If you're not subscribed to my channel yet, click on the subscribe button, and I wish you have a great day. Catch you in the next video.